Assalamualaikum and hi everyone. Let's continue our lesson on the last lecture for this topic, lecture 4 of 4. For this lecture, the learning outcomes are to introduce the central limit theorem and to solve binomial probability problem using the normal approximation with continuity correction. The central limit theorem states that if you have a population with mean and standard deviation and take sufficiently large random sample n from the population with replacement, then the distribution of the sample means will be approximately normally distributed. So what is the condition of central limit theorem? The sample size n is sufficiently large. N is greater than 50. The sample are independent and identically distributed random variables using the sampling is random. And the third one, the population distribution has finite variance. For approximation from binomial distribution to normal distribution. Based on the central limit theorem, the binomial distribution with n trials and probability of success, P get closer and closer to a normal distribution as sample size increase. Binomial distribution is approximated to normal distribution when the following conditions are met. The first one, the sample size is sufficiently large, that is n greater than 50, and p is greater than 5, and the range of success probability is from 0.1 to 0.9. If all conditions are satisfied from binomial distribution, we can approximate it to normal distribution by using NP and NPQ. Note that mean is equals to NP and variance equals to NPQ, where Q equals to 1 minus P.
Okay, continuity correction. The binomial distribution applies to discrete random variable, whereas the normal distribution applies to continuous random variable. So we need to make some correction for continuity as follow. Okay, example. If x has a binomial with n equal to 80 and p equal to 0.3, use the normal distribution to approximate the binomial distribution. Okay, look at the question and we see that n equal to 80, so n greater than 50, so we must use normal distribution. So mean equal to 80 times 0.3, we get 24. Variance equal to 80 times 0.3 times 0.7 equal to 16.8. So we write x has a normal distribution with mean 24 and variance 16.8. For A, px equal to 14. Do continuity correction. Okay, with this diagram we can understand better. Okay, we draw x equal to 14. The graph is only one line, so no area. So we must add 0.5 to 14, we get 14.5, and minus 0.5, we get 13.5. So 9 become an area. We can write px greater than or equal to 13.5 and less than equal to 14.5. Okay, we change to z. Okay, we get pz greater than or equal to negative 2.5 2.56 and less than equal to negative 2.31. Okay, we draw the graph for Z's distribution and draw a line negative 2.56 and negative 2.31, and the area is between this line. This value is in negative side, so we change to positive side. So we write Pz greater than or equal to 2.31 less than or equal to 2.56, and we take Pz greater than 2.31 minus Pz greater than 2.56 and read from table. We get 0.0104 minus 0.00523, and the answer is 0.00517. Okay, for B, Px greater than or equal to 15. Okay, we do continuity correction. Okay, we draw line and we know the area is on the right side because x greater than or equal to 15. So we add 0.5, we get 15.5 and minus 0.5, we get 14.5. Px greater than or equal to 15 mean 15 must be in the answer. Okay, if we take Px greater than or equal to 15.5, 15 is not in our answer, so take Px greater than or equal to 14 as answer. So Px greater than or equal to 14.5. Okay, we change to z. Okay, we get Pz greater than negative 2.31. We picture-wise and sketch area greater than negative 2.31, and the area is greater than 0.5, and the line in the left side, so we must change to the right side. So we can take 1 minus Pz greater than or equal to 2.31 and read from the graph, and the answer is 0.9896. Okay, C, Px greater than 13. Okay, we do continuity correction. We don't want 13 as a answer, so we take Px greater than or equal to 13.5. Okay, change to z. So we get Pz greater than or equal to negative 2.56 and picture wise, and we change to right side. So the answer 1 minus Pz greater than equal to 2.56, and we get 0.99477 is an answer. Okay, D, Px less than 17. Okay, do continuity correction. 17 shouldn't be in our answer, so we take Px less than 16.5. Okay, just change to z, and we get P less than negative 1.83, and picture wise negative 183, and so we change to right side. We can write Pz greater than or equal to 1.83, so the answer is 0.0336. E, Px greater than or equal to 11 less than equal to 16. We do continuity correction. 11 must be in our answer, so we take 10.5, and 16 also must be in our answer, so we take 16.5. This is our picture for this question, and change to z. We get Pz greater than negative 3.29 less than negative 1.83. Okay, and we change to the right side. So we take PZ 1.83 minus PZ greater than 3.29. Okay, read from table and we get the answer 0.0331. Okay, E P X greater than or equal to 13 and less than equal to 29. Okay, 13 must be in our answer, so we take 12.5, and 29 shouldn't be in our answer, so we take X less than 28.5. Okay, so we change to Z. We get Z greater than or equal to 2.81 less than 1.1. Okay, from the graph we can take 1 is the area for the whole graph minus pz greater than 2.81 minus pz greater than 1.1. Okay, we read from table and get 0.86182. An antibiotic is used to cure a certain disease with a probability of 0.85. A. If 4 patients are given the antibiotic, find the probability 1. Exactly 3 patients are cured. 2. At least 1 patient is cured. From this question, we can describe what is X. Let X be the number of patients are cured. So X has a binomial distribution with n equal to 4, p equal to 0.85. Find the probability exactly 3 patients are cured. Okay, we can write as px equal to 3. Okay, for this question, we can use either formula px equal to r equal to n cr p to the power of r q to the power of n minus r, or we can use table. Okay, if we use formula, we substitute x equal to 3 in the formula. So okay, px equal to 3 equal to 4c3 0.85 to the power of 3 times 0.15, and we get 0.3685. Or if we use table, because of p equal to 0.85, we cannot find in the statistical table. We use q equal to 0.15. So y has binomial distribution with n equal to 4, p equal to 0.15, but the question is x, so we must change to y. So px equal to 3 equal to py equal to 1. We take 4 minus 3, we get 1. We must change to symbol greater than or equal to. So py greater than or equal to 1 minus py greater than or equal to 2. Get the answer is 0.3685. Okay, for question 2, at least 1 patient is cured. Okay, px greater than or equal to 1 and py less than or equal to 3. We must change to 1 minus py greater than or equal to 4. Okay, read from table and we get the answer is 0.9995. B. If 600 patients are given the antibiotic, find the probability that 500 to 515 patients are cured. Because n equal to 600, we cannot find in the statistical table. We use approximation from binomial to normal. So X has a normal distribution with mean 510 and variance 76.5. For B1, the probability that 500 to 515 patients are cured, we can write as Px greater than or equal to 500 and less than or equal to 515. Okay, we know we must do continuity correction. So 500 must be in the answer. So we take 499.5 and 515 also must be in the answer. So we take 515.5. We change to Z's distribution and we get Pz greater than or equal to negative 1.20 and less than 0.63. And picture wise, we get the area is between negative 1.20 and 0.63, and we know we can take 1 minus Pz greater than 1.20 minus Pz greater than or equal to 0.63. And read from table, and the answer is 0.6206.
For B, we want to find the value of n such that the probability at least n patients are cured is 0.9. So P for x greater than equals to n is equals to 0.9. Okay, don't forget to use continuity correction. So x is greater than equals to n. Okay, because it has equal sign, greater than and equal, so n minus 0.5 equals to 0.9. Then we need to standardize, so z greater than equals to n minus 0.5 minus with mean 510, then divide with standard deviation, that means square root of 76.5 is equals to 0.9. We can simplify 0.5 and 510, so n minus with 510.5 divide with square root of 76.5. Now we want to look the area in the bell shape. N minus 510.5 over Z 76.5 should be on the left side. Okay, because the value is more than 0.9. Okay, the value of probability. So to get the value of n, we need to find the value of the other area. We can use 1 minus P z less than equals to n minus 510.5 over square root of 76.5 is equals to 0.9. Simplify. It will be equals to 0.1. Now we can read from the table. Okay, refer table 4. The value will be 1.2816. It has negative in front of the value because n minus 510.5 over square root of 76.5 is on the left side. Now we can find the value of n. N minus 510.5 over 76.5 is equals to negative 1.2816. Therefore, n equals to 499.29. Okay, we round off the value because it is the number of patients. 499 patients. A farmer finds that the weight of pumpkin on his farm has normal distribution with mean 3.55 kg and standard deviation 0.3 kg. Okay, let's define the value of x. So our x be the weight of pumpkin from the farm. Then we need to find the information from the question because it is normal. So we need to find mean and standard deviation. Both are already given in the question. Make sure both are in the same unit. Our normal distribution is 3.55 and 0.3 square. Okay, we have square. Okay, for variance. For A, we want to find the probability that a chosen pumpkin from the farm has weight between 3.25 kg and 3.7 kg. So P, X between 3.25 and 3.7. First, we need to standardize. 3.25 minus 3.55 divide with standard deviation 0.3. Simplify the value, we will get Z between negative 1.00 and 0.5. In the bell curve, this is the area. We can get the value of the probability by minus, okay, the area for both sides. So 1 minus Pz less than negative 1 and Pz greater than 0.5. For z less than negative 1, the probability we can read from z greater than 1. Okay, give the same value. Refer to table 3. The value is 1 minus 0.1587 minus with 0.3085. And the last answer is 0.5328. For B, 500 pumpkins have been chosen at random. Find the probability that at most 245 pumpkins have a weight between 3.2 kg and 3.7 kg. For this question, our X now is the number of pumpkin weight between 3.25 and 3.7 kg. Because it gives us N, that means 500 pumpkins. Okay, so we need to use binomial distribution. How can we find the probability? We use, okay, the probability that we already get from part A. So our binomial, okay, is with N 500 and P from part A 0.5328. So we can see that our N is extremely large. That means we have to approximate to normal. So we need to find mean. So mean equals to NP. We will get 266.4. Okay, now let's find variance or sigma square. The formula is NPQ. We can find Q by using 1 minus P. 1 minus 0.5328. So 500 times 0.5328. Our Q is 0.4672. It is equals to 124.46208. Our normal distribution will be equals to 266.4 and 124.46208. So we will use this distribution to find the probability. Okay, we want to find the probability, okay, for at most 245 pumpkins. So x less than equals to 245. Okay, don't forget to do continuity correction because it is less than and equal. So after continuity correction, it will be 245.5. Next step, we standardize. Z less than equals to 245.5 minus with mean, divide with standard deviation. Okay, square root of 124.46208. The value will be Z less than equals to negative 1.87. We only use two decimal places, okay, because we want to refer it in the table. Negative 1.87 is on the left side. So we can find the value, okay, by reflect it to the right side. So PZ greater than equals to 1.87. Okay, refer to table 3. We will get the answer of 0.0307. For C, 250 pumpkins have been chosen at random, and the chance that at least K pumpkins have a weight between 3.25 and 3.7 kg is 94.18%. Find the value of K to the nearest integer. So let X be the number of pumpkin weight between 3.25 kg to 3.7 kg. Okay, so now we have 250 pumpkin. Okay, this is our N. Okay, N is equals to 250. Okay, because X is the number of pumpkin weight between 3.25 to 3.7 kg. So we use probability from, okay, part A, 0.5328. Okay, we use binomial distribution because the parameter given is N and P. But the value of N is extremely large. Okay, N is greater than 50. So we need to approximate by using normal distribution. So to use normal distribution, we need to find mean and variance. So mean N times P. Okay, the value is 133.2. For variance, NPQ. Okay, our Q is 1 minus P. Q is 0.4672. Variance is 62.2. 23104. We can write normal distribution with mean and variance. Now let's proceed to find the value of k. So the question, okay, said that at least k pumpkins have a weight, okay, between 3.25 kilo and 3.7 kilogram. Okay, is 94.18%. So at least, okay, the symbol is, okay, greater than and equals to k. Equals to, okay, we take the percentage as our probability, okay, 0.9418. Okay, now we want to use the approximation, okay, that we already find. That means we need to do the continuity correction. What is our normal? 133.2 and 62.23104. The correction is k minus 0.5. Standardize. Okay, before we can use the standard normal table. Minus with mean. Then divide with, okay, square root of variance. Okay, divide by standard deviation. So in the bell-shaped curve, okay, our value will be on the, okay, left side. Okay, 0.9418, more than half. Okay, we can simplify 0.5 and 133.2. So it will be 133.7. Okay, this area is 0.9418. Okay, to solve for k, we need to, okay, use this area. Okay, 1 minus that area. 1 minus p, z less than equals to k minus 133.7 divided with 62.23014. Okay, simplify the value. Okay, 0.0582. Okay, this area. Okay, the value for this area. Now we can refer to table 3. From table 3, you should get 1.57. Okay, we need to put negative in the front. Okay, because it is on the left side of 0. Okay, now we can solve for k. K minus 133.7 divide with square root of 62.2314 equals to negative 1.57. So our k will be equals to 121.31. Okay, but the question want to find the value of k to the nearest integer. So k is equals to 121 pumpkins. So that's all for topic 7, normal distribution. Okay, don't forget to study this topic for your PSPM. Okay, all the best.